Hello and welcome to episode 1.1. Today we'll be talking about the basics of logic and the uses within mathematics. So what is logic? Logic is the study of reasoning and truth. So basically, if you're trying to figure out if this certain equation or this certain law or mathematical rule works, you can use logic and what is called mathematical proofs to figure that out. So logic is typically very formal and has a lot of strict rules. This is done to prevent ambiguity. Okay, so let's say you have mathematician A, and he's named Bob, and another mathematician named Billy. So if Bob writes a proof for an equation that he made, but there's no strictness or formality, Bill, or the other person, might not know exactly what he's saying. Or let's say that someone looks at his logical statement, say 10 years later, are they going to have the same idea? So that's why formality and strictness, in terms of like how you write the actual logical proofs, that's why it's important, is to make it like as rock solid as possible. So a large aspect of logical arguments, or of logic, are logical arguments. So a logical argument aims to derive a truth or fact. So basically, here's an example. So again, a key aspect of logic is that you start with maybe some known or predetermined facts. So let's say you know this is true, and you can say that this is true because I don't know, someone derived 100 years ago that, say, the area of a rectangle is width times height. And you can say, alright, I'm going to build on top of that. And then you can create you can either state another known fact or you can build on top of this one. And you keep doing that for as long as you need to until you get to your final statement, and this is called your conclusion. This is basically what you're trying to prove. So if you're trying to prove that the area of a circle is pi r squared, this is where you would say, therefore, the area of a circle is pi r squared. So let's look at some uses of logic. So in mathematics, logic helps find and create rules, laws, and formulas. So for example, the area of a rectangle. This did not just pop out of the air like 100 years ago. Someone probably maybe many hundreds of years ago derived this formula by using logic and mathematical proofs. They probably started with, okay, so first off we need to define a rectangle so that we know exactly what we're talking about. A rectangle is a quadrilateral, so it has 4 sides, 4 angles, and then you can state, I'm trying to erase this, but it's not working. Okay, there we go. You can say that it has 4 angles, and then you can say that every angle is equal to 90 degrees, and so on. So, and this is the symbol for angle, by the way, just quick geometry fact. But to get these kind of formulas, you need to use logic and mathematical proofs. So if you have a pre-algebra or algebra class, you'll know this equation is basically just the slope and y-intercept of a linear line. So again, this was not just thrown up in the air and this is how it landed. There were complex proofs, and there's a lot of logic involved in order to say that this works for all possible linear functions. So as a quick recap, logic is the study of truth and reasoning. So basically, logic is trying to figure out what is true, what is 100% true, why is it true, and building on top of truthness. A logical argument is a form of logic that aims to find the truth by using previously found truth. So again, in our previous example, you have known fact number 1, 2, and then you can say, because 1 and 2 are the way that they are, therefore 3, and then you go all the way down until you get to your conclusion, which is therefore, and then your law, rule, or formula that you're trying to find. And then, of course, logic can be used, and this is just in the field of mathematics. There are also like 100 other fields that also use logic. But in the sense of mathematics, it can be used to prove rules, laws, and formulas.